in our WhatsApp group. Let us discuss the statistics in a little higher level. Okay, the last class we have seen the statistics can be descriptive statistics, okay, and inferential statistics. Now there are one things I would like to discuss about the descriptive statistics. Like last time we have discussed our true value of a tablet. Okay, we have taken around 140 mg, and we have taken the samples out of the manufacturing batch that we have prepared. Our sample is 100 mg, 120, then 140, 145 and 150. Okay, and in descriptive statistics we have calculated the median value, which is the mean value, okay, then the mean value and the mode value. Mode value, of course, there is no specific mode over here because there is no repetition of the value, okay. But if it is then we have seen 131 as a average score. Now what happened if we get one value which is known as outliers or outliers, okay, around 300 mg. Now this 300 mg tablet is outliers because it is not coming in the range, nearby the range at all. So in that case we have to perform a Q test known as Dixon Q test. Okay, this Q test is something which generally gives us an understanding instead of Z value, instead of Z score, that what we are taking in inferential statistics, we can get in the Q test by taking outliers. How? Now what is the formula of the Q test? The Q calculated value is nothing but your gap upon the range. Okay, now the gap is nothing but the suspected value minus nearest value. Gap is nothing but suspected value minus nearest value upon the range is nothing but higher value minus lower value. That is a range. Higher value minus lower value. Now if the Q calculated, we have a table like Z score. Okay, we have seen that 0.6 is around 50% and 1.9 is around 95% confidence. If the Q calculated value, if it is less than the Q mentioned in the table value, then we have to reject. If Q calculated is higher than the tabular value, okay, which is mentioned in the table, then we have to reject this batch, or you have to reject the hypothesis, okay, that it is nowhere significant. Okay, so it is a descriptive statistics, but we are using it in an inferential statistics by taking an outliers. Okay, that is mentioned in your syllabus as well. But very frankly speaking, in nowhere in any university syllabus the statistics is not organizedly given. Okay, it is randomly. So Q test is one of the tests that you have. So I thought I should explain you. Okay, so you remember it's one of the descriptive statistics where we are using these statistics for an inferential purpose by taking the outliers. Okay, so that's all. Then next comes to your different type of inferential statistics that we have seen. Now the entire statistical test we can classify into the statistical test can be classified into parametric test, parametric test and the non-parametric test. Non-parametric test. Now, what is the meaning of this parametric test and non-parametric test? Parametric means parallel measurement. Whenever we have two different groups that I have already mentioned, group 1 and group 2, we are measuring something parallel measurement. Okay, so I have some of the parametric test already I have mentioned. That first parametric test, your paired t-test, and the formula also I have explained. Then if we are measuring the variance, analysis of variance, then it is ANOVA. Okay, now in discussing the ANOVA, if it is there are two type of ANOVA again, that is one-way ANOVA and the two-way ANOVA. When we are taking this group 1 and group 2, when these both groups are depending upon the single variability or single, you can say